Assalamu alaikum and hello everyone. Welcome to the Unit 4 of Soil Mechanics. As you know, my name is Engineer Naveed Ahmad and today we will be discussing one of the most important topics in geotechnical or in civil engineering or in soil engineering, soil mechanics, classification of soil. So as you can see, our reference book is book Principle of Geotechnical Engineering, and it is the unit we will cover about 1 to 50 pages of the book. So let's start it with slide 1. First, let's talk about the soil classification system. What is soil classification system? So what is soil classification? It is the process of grouping soil into categories based on their engineering behavior. This makes it easier for us to concisely describe soil properties instead of writing long technical description. We can say in simple terms, we are turning something very complex, the infinite variety of soils, into a system that engineer and soil scientists can effectively use. So you can say here's the same. Classify soil into groups and subgroups according to their engineering behavior to concisely express the general characteristic of soil with infinitely varied without a detailed description. So what does it mean? As we know that there are different peoples or group of peoples, they use the soil for different purposes, like the agriculture zaraat they are using for the farming, like plantation and vegetation purposes. So they deal soil with this aspect. Soil scientist or geotechnical or geologist, the geologist, they are looking or evaluate the soil with the geology aspects. So here we are dealing with the civil engineering aspect. So we check the soil behavior under different loading condition. So we are interested here, what is the behavior of soil? This is a soil. What is the behavior of soil under different loading condition? So how much the shear strain, what is the shear strength, axial strength, compressive strength, compressibility, settlement, these type of properties we are going to elevate for the soil. So, being the civil engineer, we are just interested in this. And as we discussed, the soil scientist or the geologist or the agriculture scientist, they are dealing with their own aspects. So that's why we are described or divide the soil into different categories. So in simple, you can say soil classification system are divided into two main groups. The first one is one system designed for the engineering purpose, and the another one it is designed for the soil scientist. So here we are interested with the engineering purposes. So no soil classification system for engineering purpose are generally into three categories. The first one is USDA, for its full form is United States Department of Agriculture. It is used in soil classification like USDA developed textile soil classification system, or some of the time it is called soil texture triangle, sorry. And it is mainly used in agriculture, soil sciences, environmental studies to describe soil textures like sand, silt, and clay. So you can say to determine the soil fertility, water holding capacity, and sustainability or suitability of farming. So it is generally used for the sake of food for the agriculture purposes. The another one is AASHTO. It is very important for the roads. So AASHTO means its abbreviation is American Association State Highway and Transportation Official. So AASHTO created a classification system used in highway and road engineering. It is mainly used in highway and road engineering. It helps to evaluate soil for pavement design, subgrade strength, and road foundation. For example, you know soil subgrade. What is the subgrade? This is the ground level, and this is the ground level, and this is our formation level. FL here we are going to make our road. So now this soil which is in the foundation, which is directly under the road, so this soil is called what subgrade. So we should to evaluate this type of soil by mean of AASHTO. Either the soil have the capability to take the upcoming load, what type of soil classification. So these all we can evaluate by the AASHTO. In USDA, we can evaluate the soil only by particle size, means it is 10 mm, 30 mm, 50 mm. by sieve analysis or particle size distribution. AASHTO we can use two terms. One is by particle, and also we can use by the Atterberg limits, which is plasticity and plastic index or liquid limit. The third one is USCS. It is Unified Soil Classification System. It was originally developed by the US Army Corps of Engineering and US Bureau of Reclamation. It is widely used in civil engineering and geotechnical projects to classify soil foundation, embankment, and the geotechnicals like retaining walls and general construction work. So it is used for both in roads and buildings. And how can you evaluate? It can evaluate by both particle size and plasticity. So we will see this all three in very detail in the upcoming slides. Know why is soil classification important for civil engineers? Because the type of soil directly affect the suitability or stability and performance of structure. Accurate classification help us determine whether a soil is suitable for the construction and ensure long-lasting foundation or not. What does it mean? It's mean, for example, if we are going to construct a, sorry, this is a 10-story building, 10-story building. So it's structural design. Structural design means design of beam, column, slab, footing, foundations. All the structural elements are very well designed, very well designed. It is very strong. But the soil on which this building is rested and the soil on which the building is built. So this soil is not good. Their bearing capacity is very less or it is not good. So what will happen if we design this slab or if we constructed this building? So after some time it will settle down because if the soil is what porosive, so the soil it will become settled down. So if it settle down, so it may be crack or broke, partially settled or fully settled, so it may be break the building or the building cause what a large amount of cracks or it may be disturbed or it may be destroyed or break from one side or fully. So here you can say the structural design is very well, but we didn't evaluate the site at the beginning. So for the suitability for construction, it is mentioned here, it is very important to evaluate or to check or to analyze the soil before construction of any civil engineering project. It may be road, it may be structure, building structure. So it is very important for the stability and long lasting and for the long time. So now, how can we soil classification system based on simple index properties such as index properties as we discussed in the previous indicator which give us index means like a numbers through which we can indicate either it is good or not. So there are two. One is the particle size distribution. Okay, for example, from sieve number 200, if it is past 35, more than 35 or less than 35, so it is the particle size. What is the particle size? And another one is plasticity. This indicates the soil ability to be molded or deformed without cracking. This measure using in Netterberg, which is included liquid limit and plastic limit. We have discussed this in very detail. What is plasticity? Plasticity is the property or ability of soil from which we can make any shape from the soil, from the clay without crumbling or without breaking the soil. So we can evaluate the AASHTO soil properties, one by particle size distribution and another one is plasticity. You know, you can see in this slide type of soils. This is sand, silt and clay. Clay is the most finer, so you can say this is the size. If you can see with respect to size, sand is bigger. You can say it is bigger than silt and silt is bigger than clay. we can discuss it in very detail. So now we are going to discuss each of these one by one. The first one is USDA, which is United States Department of Agriculture. So this classification method is based on the particle size, as we discussed before. This system use a soil texture triangular to classify the soil into categories. So here you can see three types of soil. It is clay. It is from 0 to 100. Sorry for the line. 0 moves up, it is 100, it is 0 at this for the silt, and as we move down, so it is 100, and from the sand it is 0 here, and it is finished at the end. So this is sand, silt, and clay. Once we find out the percentage of sand, silt, and clay, so then we can find out type of soil. Either it is clay loam, it is clay, it is silty loam, it is loam, it is sandy loam. So we can find it very easily. So this triangle is called what? Isolateral, or it is called equilateral triangle. Equilateral means all the three sides of the triangle are same. No, textural classification. What does mean texture? Textures mean the surface of appearance. Like this is, so this is aggregate 1, this is aggregate B, A and B. So now you can see their surface, it is polished and it is smooth. So you can feel, how do you feel the outer surface of the aggregate? In simple, it is called what? The texture. So its feeling is what? It is smooth and polished. So it is their textures, and their texture you can see it is angular and it is rough. So this is what it is called textures. Cell texture is influenced by the size of individual particles divided into the categories. So there are categories. In this, we have only three type of soils. The one is from 2 mm to 0.05, it is sand. From 0.05 mm to 0.02 is clay. If it is less than 0.002 mm, it is called clay. So if it is greater than 2 mm, it is all what? Gravel. All the size are considered gravel, and this is not present in USDA soil, so it is not considered as a soil. So only this from 2 to 0.05 sand, silt, and clay. If it is more than 2 mm, so it is not considered as a soil. So now we are going to try a question. Okay, there is one rule in this. If we take a soil sample, this is a soil sample. So in this soil sample, it is possible that some of the grains or particles, maybe they have a size more than 2 mm. Okay, for example, if I take 100 gram of soil, so you can see if there is 100 gram of soil sample, we take and put it in the sieve. This sieve is 2 mm. For example, it is 2 mm sieve. So now 90 gram, it is passed through sieve number 2 mm. So as per the 90 gram, this 90 gram is soil as per the USDA. But the 10 gram, it is more than 2 mm, it is written. So it is gravel. So it is not considered to be the soil as per the USDA. So it is soil, but it is not considered for the USDA system. So what should we do if it is not possible that all the soil is passed through it? If it is possible that all the soil is passed through it, so it's okay. But in case if some of the soil is retained and its size is greater than 2.2 mm, so we should do minus or subtract the value of gravel, because as per the USDA, this is the not type of soil. So this thing is simply mentioned here. So we will see this in the upcoming example, so it will be easy for us. So you can see what is the soil. For example, gravel is 10. I will just write here. Gravel is equal to 10%, sand 25. Okay, like here you can say the gravel is given 10%, sand is 25, silt is 51, and clay is 14%. So here we see this is gravel 10% and this is not part of the soil as per the USDA. So we should to minus this value. If only these three value is given to us, so we can directly go to the triangle and check the type of soil. But no, these gravel, because its size is more than 2 mm, So it is present in our sample, so we should to subtract this value. So now, as we already know, gravel is equal to how much it is? 10. Sand is equal to how much it is? 25. And clay is equal to 51. So silt is equal to 51. Sorry for the writing. And clay, it is equal to how much? 14, I think so. So now adjust the percentage. First we write the value of sand. How much is sand? It is 10. So we can, sorry, it is sand is equal to 25. Divide by 100. How much the total percentage? 10 plus 25 plus 51 plus 14. So it is equal to how much total? 100% of soil sample. So from total, we should to minus the value of what? Of the gravel. How much gravel? It is 10. So we will do adjust this value for each of the soil. Like for the sand first, sand is how much? 25 divided by total 100 minus the value of the gravel multiply by 100. So now it is 27%. Same for the silt. What is the value of silt? It is 51. So we should write 51. Total is 100 minus the value of gravel. It is 10 multiplied by 100. Same we can do for the clay. So once we have done with this all the things, so now we already know. No, there is no value for the gravels. It is adjusted. Now we have the three values for silt, sand, and clay. Now we can evaluate the type of soil very easily from this triangle. So first to understand the triangle, how can we draw a line? So you can see it from 0 to 100. So we should to, you can see here the arrow is in this direction. So we should to make a line in this direction. How much it is sand? And for the silt, it is say it is in this direction. So we can draw a line in this direction. And for the clay, it is straight. So we can make it a horizontally straight line. So now, what is the sand value? Sand is equal to how much? It is 27.7. So it is something here and make in direction. The another one is silt. It is how much? 56. So draw a line at 56. And the third one is clay. It is how much? 15. So draw a line at 15. So it is light here. So it's mean this is, you can see there is a black lines. So these are the blocks which show different type of size. So our lines, three lines are concentrated here. So it is lies here. So it's mean our soil type is what? Silty loam. So this is our soil type. So this how can you evaluate the soil very easily. What is AASHTO classification? As we discussed before, AASHTO is American Association State Highway and Transportation Official. So it is generally used for what? For highway and road material subgrade design. So if subgrade is not designed well, so what will happen? So you can see if this is the road, this is the subgrade. If we don't know about the subgrade, what type of material is this? Even the road, the pavement above the subgrade, it is designed very well. But if the load of the truck or any vehicle it is more, so what happen? This will settle down. Even it is very stronger, but the soil at the beneath it is not stronger. So what's happen? It will settle down at the end. Also, it will be cracked from here. So it will, you can see, it will demolish the or crack the overall road. So that's why the soil type it is very compulsory for each civil engineering structure or project. So now we can discuss the soil classification. There are soil is classified if it is fraction passing 75 mm or 3 number inch sieve and retain on 12, sorry, 10 or 2 mm, so it is called gravel. So what does it mean? It's mean if this is sieve number 75 mm, if the material is passed through this and this is the another sieve and it is sieve number 2 mm and retain on it, passing through it and to retain here. So this type of soil is called what? Gravel. Same for the sand if it is passed through 10 mm and received on 200 mm. 200 mm is 0.075 mm. For the silt and clay, it should be passed through sieve number 200. If it is bigger than 75 mm, so it is called what? Cobbles or boulders. So it is very clear for this image. You can say if the size it is more than 305 mm. So these are called boulders. If it is between 305 and 75, it is cobbles. And if it is between 75 and 2 mm, so it is called gravel. If it is between 2 mm and 2, sieve number 200, which is 0.075 mm, so it is called sand. If it is between 0.075 and 0.02, it is clay. If it is less than 0.02 mm, so it is called sorry clay. This is called silt. We have discussed that the AASHTO we can classify by the two things. One is the particle size distribution, as we discussed in the previous. Like if the size is between 0.02, 0.075 to 0.002, so it is called silt. If it is less than 0.002 mm, so it is called clay. So it is on the basis of what particle. The another one is plasticity or Atterberg limit. So it is Atterberg limit. Here they can say if the value is lies between the pi value, plastic index, so it is liquid limit minus plastic limit. If it is between 0 and 10, if the value is come between 0 and 10, so it is called what? Silty. If it is more than 10, so it is called what? Plastic clay. As we know what is plastic index, it is the index or number which give us how much the soil is plastic in nature. So as we know, clay is very small, so it is very small. The particles, if the particle is very small, so they have very absorb water very highly, so their plasticity is more. So here you can see if the pi value is more than 10, so their plastic index is very high, so it is clay. If the plastic index is between 0 and 10, so it is called what? CP, or it is considered to be a C. Now there is one term group index which is represented by GI. What does it mean? It is a number or index. Again, it is a number which tell us about the how much the subgrade is good or bad. In simple, he told us about the property of soil of subgrade, how much it is good or how much it is bad. So here it is given if the GI value is equal to 0, so it is considered be very good subgrade, or you can say from 0 to 5, so it is considered to be good subgrade. If it is more than 20, so it is called what? Poor or weak subgrade. This is the formula GIF 200. F200 means sieve number 200. The material, how much it is passed through number C1, like this is 100 gram, and this is sieve number 200. When I put out a soil here, so only 60 gram soil is passed here. So this is how much. This is called the material which is passed through sieve number 200. So you should to write there here the value 35 feet is constant, my 0.02 plus 0.015. LL is liquid limit minus 40 plus 0.01 plus F 200, again the same thing, minus 15 into pi is plastic index minus 10. So this formula will be given to you, so you should to know about this. If the GI value is equal to 0, so there are some rules for the GI. The same thing is discussed here. What is GI groups index, percentage passing to sieve number 200, liquid limit and plastic. The remaining 35, 0.05, 40, 0.01, 15, 10, these are constant values. So there are some important notes for the GI. If, for example, if you calculate the GI value and its answer is come minus 10, so you should to make it 0. There is no negative value for the GI. If the values come in minus, if it is minus 100 or 1000, so you should to make it 0. Understand? The another one, if for example, if the values come 9.6, so you should to round it to the nearest whole number. So we can round it is greater than 5, so we can make it how much? 9, so it is 10. So you should to make it a round number. This is the second rule. The third rule, there is no upper limit. For example, the GI value maybe 10, maybe 100, maybe 1000, maybe 10,000. It can be any value. It has no limit, but its minimum value is 0. It is not less than 0. So there are 7 groups in the AASHTO. So for the some groups, if the groups index for soil classified as A1A, A1B, A24, A25, and A3. We'll see this in the next slides. So for these all 5 groups, the GI value is always 0. And for the groups A to 6 and A to 7, we can use this formula for the GI, not the long one. So it is 0.01 F200 minus P15 Pi minus. So these are the some important rules for the GI.